here, so a little panic.
I forgot to, so we're sorted by class tonight. We're already in our classes.
We're already here. Yeah.
Awesome. Okay. Well, I've been checking the temperature of my water, so I hope y'all have some warm water. And I'm going to share my screen because I did create a PowerPoint for you guys. And I think some of you are new faces. So hello. We did some major introductions last week. Is there anybody that's just kind of new to the group this week? Do we have any new teachers? Anybody want to say hello? Yep, I see a thumbs up. Okay. We'll get started. Hi. Hi. Okay. Well, welcome. If I didn't get to greet with you last, happy St. Patrick's Day. Welcome. Right, so we're going to start, and I'll do share my screen. Yeah. Okay. Share, and then I'll do this. You don't want to see that, and we'll do this. Okay, so we're doing wheat germ DNA extraction. Can y'all see the screen? Good. Okay. Your temperature is supposed to be 55 degrees. I'm not sure if it's really that specific. I've got some pictures for you. If you can touch your water, if you can pick it up and hold it, that's usually the right temperature. So you can use a thermometer, but if you can just hold your glassware, you're probably at a good temperature. I'm not good at following all the instructions, so I'm going to do mine a little bit different, but I'll show y'all what you can do. The first thing too is wheat germ. So here's my wheat germ, and I keep it in the freezer, and this will last forever because kids don't need that much. And but when you buy it, make sure you buy untoasted wheat germ. Like don't get the toasted kind. Toasted is yummy, but not for this lab. We don't want to mess with the DNA that much. The other thing, the reason this is a really good product to use, not only because it's cheap and you can store it in your freezer, but because it's got so many sets of chromosomes. It only has 7 chromosomes, but it's a hexaploid. So when you multiply the 6 times the 7 chromosomes, you've got 42 chromosomes available for extraction. So you can get that really good snotty DNA mixture. I've used the strawberries before, and I love strawberries. Strawberries will work really well for this because they're octoploids. There's a whole interesting story about plant sex and strawberry sex, and they exchange a lot of chromosomes. So kids really like to know that. So if you compare it to humans, like diploids, you know, there's a male and a female, that's it. But plants, they're very promiscuous. And so that's a real good way to explain to kids, of course, high school kids, I think some of you are in middle school, about all of this major sets of chromosomes and replication. But anyway, short of the story is strawberries are good also, but you have to go to the store and get them. And this stays in your freezer. I put all the steps on one slide for you guys. So the first thing we're going to do is just take a jar, and my recommendation is to take the jar that they gave you with the wheat germ in it. And if you just want to pour some of that out, let's see. If you just want to pour some out and start empty, I think you'd be fine, because I have found that it's very hard to get it correct. If y'all just want to start with your tube, like just pour the wheat germ, pour some of it out on the table. And I do not measure my wheat germ. I just sprinkle some wheat germ in the bottom. So I know in the directions it said to use a spoon of wheat germ, but I really just sprinkle it on the bottom of the tube. It does not matter really how much wheat germ you're using. So you don't have to be specific. I also used wheat germ in test tubes. So just stick your wheat germ anywhere you want to. You can put it in a cup. I think they gave you this fancy beaker. Can put it in this fancy beaker. I would not worry about measuring, because this is full of chromosomes and full of DNA. So once you get your wheat germ in here, you're going to take your Goldilocks water that's the exact perfect temperature, and you're going to just pour some in. I do about halfway of whatever container I'm using. So my measurements are, more like cooking. I'm going to put the wheat germ on the bottom of my container, whatever container I'm using. Maybe I'm using a cup or a beaker, and then I'm going to fill it up about halfway with warm water. So my recipe is pretty simple. And the other part about this is don't be afraid to use anything you have. And you can micro scale this into a smaller one if you wanted to. So we got the warm water and we've got our wheat germ. Were y'all able to do that? Is everybody good with warm water and wheat germ? Think so? Then you have meat tenderizer. They sent you some meat tenderizer. I've done this without meat tenderizer. You don't have to have it, but y'all have it tonight. So if you want to use some meat tenderizer, just sprinkle the meat tenderizer in, or I think your recipe says half a spoon. But I put the meat tenderizer in, and the meat tenderizer is to break down our proteins. And then I like to use a container with a lid and just shake it up to give a good mix. If you're using a test tube, and we have lots of test tubes in our classrooms, I would just put my thumb on top of the test tube and shake. There's nothing in here that's going to hurt a kid. So you can put it in test tubes. You just put the wheat in the bottom, the warm water. And if you don't have any meat tenderizer, you'll be okay. You're still going to get results. So are y'all good with your meat tenderizer and your hot water? Okay, the last thing we got to do is a squirt of shampoo. Now there's lots of theories on this. So they sent y'all some shampoo. This is what they sent me. So do y'all have the same flavor? I see you sniffing it, Mandy. She says it smells good. All right. This is hotel bottles of shampoo. It's sink detergent, hand soap. It's just got to be soap. It's going to break down the lipid bilayer. It's just going to break down. It's actually, if you want to compare it to an enzyme, it'd be like lipase, but it's just breaking down some lipids. So you put your soap in, and at first, when I first did this experiment, I thought a little bit of soap was a good idea. It's not. A drop of soap is not going to work as well as a good squirt of soap. So I'd give it a nice little good squirt of soap, put the lid back on there and shake it up. And then you're just going to let it sit. And I, at first, when I did this, thought, I don't need to use that much soap, but I got better results with a healthy dose of soap. So, and then we're just going to let that sit. I probably shouldn't put it on my hot plate, but it shows really good on the hot plate with the camera. And you're supposed to let it sit for 15 minutes. Oh, and if you didn't want to shake, you could stir. So if you're using a cup and you're using plastic spoons, like some of you have some digital learners at home, all they have to do is stir instead of shake. And I'm sure they have soap at home. And if you wanted to take the meat tenderizer out of the experiment, you could. You could just send them some wheat germ. And actually, this procedure should work with just about anything that you could crush up in your yard, that you get down to the finer layer. If it's got something like coarse shell on it, because if a wheat has a shell casing around it, and this has been refined and taken off, but there's a lot of things that you could get kids to experiment with that are softer, and you can get into that DNA, into that cell. So like a strawberry is pretty soft. This is pretty soft. So if it didn't have a tough carbohydrate outside cell wall layer, like I wouldn't try tree bark. I don't think that would work. So if you have kids at home, I think there's a lot of things that you could let them try if you couldn't send them wheat germ. Okay, next slide. So we're gonna let it sit for 15 minutes. I'm gonna, I guess I'm gonna start a timer. I have let mine sit all day. Like if kids have left class and this is the only thing we got done, it can just sit just like that. The alcohol's the fun part at the end. Alcohol is always the fun part at the end, but it's just, it can sit till the next day. So 15 minutes is not critical for this activity. You really are just looking to leave it alone and let it separate out on its own now that you've mixed everything. But one of the things that's really important is the polarity of water. And next week, we're going to be talking about polarity and with chromatography. So I really like this picture that we had. Water is polar. So I've got a picture of water here. Kristen, are you monitoring the chat? I see it popping up. Is there something, do I need to slow down? Is somebody, I talk fast. Do I need to slow down?
Nobody asked to slow down yet, but
I see the chats going off.
so Libby asked, does it need to stay warm while it sits? But I think you answered that because you said you can let it sit out all day
Yeah.
long.
Yeah, the other part that you're doing with the warm is it's breaking down the cell membrane and the cell wall, and that's part of the shaking too. And it's going to cool off, and that's fine. The warm is not really critical to continue it being warm. So it's that initial warmth, and then I think you're good. Any other questions?
I was just noting that everybody has some sticky notes in their binder in case for these helpful hints you want to write on a sticky note and put it within your binder if you don't want to scribble all over your papers. But there's also, you can also print off another set of this curriculum that's in the Google file. But that's it. But I'll keep you apprised of the chat.
I do talk a lot, and I do get hyper excited on things, and so my students are good at stopping me. Y'all got to stop me if I'm going too much. All right. This actually, all the steps that we did prior, I kind of explained. Like the hot water is lysis, breaking up the cells. The germ is the wheat germ is your DNA source. The meat tenderizer breaks down proteins, and that should make a lot of sense to kids. Like, what do you use meat tenderizer on? They're like, steak. Right. So it's the same thing. Some people hammer the steak, but so the meat tenderizer is breaking down proteins, and proteins are inside the cell, and they're binding that DNA together. They're wrapping that DNA up. So that's the role of the meat tenderizer. But I have found that because this is a really good soft like DNA source, and I don't even know if that's a good way to describe it, the meat tenderizer is not as necessary. And then the squirt of shampoo is helping to break down the cell membrane. So my next slide is really like about the alcohol, like what's happening with the alcohol. And the alcohol is about polarities. So water's polar. So I've got the Mickey Mouse water at the top of the slide, and your hydrogens are positive and your oxygen is negative. And polarity is defined by having a charge. So water is a really, one of its amazing properties is it likes to be attracted to things. A lot of things will dissolve in water, and it's because water is polar. Well, one of the things that dissolves in water or is attracted to water is DNA. And that would make sense because there's DNA in our cells, and our body's made of a lot of water. So DNA is polar, water is polar. And one of the rules is polar likes polar. They really do. They like each other. They're highly attracted. And non-polar likes non-polar. And we've all done this with salad dressing, shaking up the salad dressing, the Italian dressing, it separates out. This is oil and water. So polar likes polar and non-polar likes non-polar, but polar and non-polar, if they were in the same room, you need to separate them, probably call their parents and give them a behavior contract. They don't play well together. You like both of them, but together they are not a good mix. So alcohol is non-polar. So when we add the cold alcohol, which I hope y'all have in your freezers or your refrigerator on a bucket of ice, what's going to happen is some separation, and it's all based on some polarities. And so it's basically the alcohol is going to pull the DNA out of solution. The DNA is going to try to get as far away from the alcohol as possible. So these are my results, and I did it a whole bunch of different ways. And DNA looks like snot. It does. It just looks like a white booger. So when you got it, you know you got it. And you just got to tell the kids you're looking for a white snotty booger, and they'll find it. So I have results from doing this week. I've had some students doing some stuff, but these are the same test tubes, but the pictures are better. But the DNA has held pretty good. And then my jars. And every one of them, and I'll show you at the end, because we did different, we've tested different variables, but it's that white snotty stuff. And I don't even know where here's my best jar. Nope, it's separated out. So my really good picture off to the side here, the black jar and the big pitcher with the lid on it, that's my best DNA sample. That's a really good chunk of DNA. So that's what we're hoping you get. So one of the things that you can do is, because these materials are so inexpensive, I mean, these things are cheap. It's a great opportunity to let kids play with independent variables. Let kids change the variables. DNA is the dependent variable. That's how much is extracted, like how much DNA can you get out based on whatever. So students can change how much meat tenderizer or have no meat tenderizer. They can work with how much soap. And then I threw salt in there, but they can change all of these variables and run different experiments. So these are mine that we ran this week, and I put some notes underneath them. So this was too much soap and no meat tenderizer, and the DNA's in the middle, the white boogers. This was a drop of soap, and it's pitiful. This one is just a drop of soap. Then I have a drop of soap and no meat tenderizer. So see, the soap is huge. And then on the very end, I have a big squirt of soap. Also, now one of these had meat tenderizer. I see a typo. No tenderizer. Oh, the last one had meat tenderizer. I've got a typo. I'm sorry. But my best results were too much soap. Are y'all good on changing variables? Does anybody have any questions about variables? Students have a really, really hard time with variables. I do a lot of science fair projects, and I have found if I will pick one thing, and that is my variable for the year, we'll go back to that every time, and we just use one really good example that everybody did, and then apply our own projects. But okay. No questions out there? The other thing that's not a part of this that was in your RTI is salt. And I was kind of surprised that salt wasn't a part of it, because salt is used in a lot of DNA extractions. Because DNA has a negative charge, the salt kind of neutralizes that negative charge and makes it less attracted to water. So the salt can help bind on those phosphate ends of the DNA, and it will help DNA fall out of water a little bit more better. All right, I don't even know what time we have, but I wanted to show y'all something. When you talk about DNA, one of the things that you should ask your kids before you get started is, what do you think of when you think of DNA testing? And these are some answers that I typically get from kids. Cops use it, it's found in our blood, in our hair, or it's in the nucleus of the cell. And then you say nucleus and somebody starts talking about a proton, you know, it goes sideways fast. Who's your daddy? That kind of stuff. So those are the kinds of responses I get from kids. I want to share with y'all, this is after innocence, because I don't think our kids think about us, that DNA can exonerate somebody. I think we always kind of put DNA in as that you're going to convict you and send you to jail. So I'm hoping this will work, because I'm not a Zoom teacher. Y'all are the first group that I have shared a video with, and I'm just going to show you some clips from this film. Let's see. Nope, let me pause. Sorry. Video track. Nope, audio. Title. DVD menu. Whoops. And some of you are not going to be old enough to remember this. Some of you will. Oh, goodness.
Is this a movie?
Yes, and it's on Amazon. It's expensive on Amazon, but if you do the cheap version, you can buy it for people for $2.99, $3.99, and it might even be on YouTube. So we're just going to watch maybe 4 minutes, and I'm going to skip around, but here's the beginning of the project. Can y'all hear and see that?
We can see it, but we can't hear it.
Well, I had it.
There should be in the bottom of your Zoom where you can add sound.
Yes.
Bill Donahue days.
I can do it. I've done it before, but I can't stop this stupid video. All right, I just hit X. All right, so now I'm going to go down to my share screen. I might have to unshare. I might have to stop share and reshare. All right, let's see. It might be on Netflix. All right, I'm going to do share screen, and I'm going to go to advanced, and then I click on the video. Now you'll be able to hear it. If those of you that haven't done that before, that's where it is. I am sorry. Title. Does anybody remember Phil Donahue?
Oh, yeah. We can hear.
Okay, good. Let me get to the DVD menu and we'll get to Phil and see what Phil's got to tell us.
I was in prison down in the music department, and a guy called down and he was like, turn the Phil Donahue show on, turn the Phil Donahue show on. They're talking about DNA.
How come they're out? How come these men are free? Because DNA testing proved that they didn't do it. They didn't do it. And are you here to say that these young men are the tip of the iceberg?
Now, through DNA, we have hard evidence that there is a lot more mistakes being made than we ever expected. That means that there are thousands of people in jail today who could prove their innocence with DNA tests, just as these gentlemen did.
After having featured Barry.
All right, now I'm going to forward it to another track at the end, and then I'll tell you how I've used this in my room. If it will open. Okay.
You face it and you try hard, but you ain't gotta serve a drink to be behind bars. I've been locked up and the keys been thrown away, taken so far away from my family. No more Sunday dinners, no more midnight chat. Please don't cry, my lady, I'll be back one day. There's some cruise shit to face, prison and lifting gates, people from a different race.
Can you read what the words are saying? It's hard to see.
Ronald and Jennifer continue to raise awareness about problems with eyewitness identification. All of these men are exonerated based on DNA evidence. Calvin's studying for his GED to get a barber's license. He's looking for a full-time employment.
You can't sleep, it ain't sweet on a night shift.
Morning. So what's new today?
I'm walking above the ground.
Oh,
You're just so wonderful.
oh, thank you so much.
Thank you.
How you doing?
Fun.
Finally. Great.
At 42, Wilton hopes to start a career in family. Florida has no law to compensate the wrongfully convicted.
This is my little thing. DNA, or deoxyribonucleic acid, that's God's signature, okay? God's signature is never a forgery, and his checks don't bounce, all right? So we all...
Okay, so I'm gonna stop share. All of those men served 20 plus years. It goes into their stories. It talks about how they can't get their records expunged. So, and they still have to check the box that says they're a convict. I guess I'll go back to share screen so y'all can see my my PowerPoint here. But one of the things that I'll do is I'll just make a list of their names and then let them kind of just write whatever they want about their names. And then I assign poetry or art based on what they think about DNA evidence. And it does sometimes leave the realm of teaching in DNA, but I also think it provides a lot of relevance. I think we're raising citizens that need to be aware that it can also be used to exonerate people. And then some kids get really interested into the backlog of DNA information. If you combine it with something as simple as this and saying DNA is in everything, and it's, and I really like what he says at the end, that it's the blueprint and the checks don't bounce. Like, it is so individual. So it's a very powerful thing for kids to consider. I will say that I would be fine with a middle school seeing it. It does have some profanity in it here and there, and it does it talks about, a lot of them are convicted of rape. So, but they've all been exonerated, and some of them were on death row, and DNA got them off. So it's an interesting, different way to do it. So now I think we're ready to do that. Now I've done the serious, let's get the alcohol. So are y'all ready to add some alcohol? Or does anybody have any questions? All right, well, I'll go to my freezer and I'm going to get my alcohol. And this is what I've learned about this alcohol ratio. It really needs to just be half and half. So whatever container size you're using, you need about half of it to be the alcohol. So if you're using a small container, less alcohol. So teachers, you know, sometimes resources are limited. You know, this sells for $1. Kids are way more familiar with this, and a lot of kids have this at home. They will not see the DNA without the alcohol because we're coming down to our polarity rules. The cold is important because it helps to keep the alcohol, it keeps the DNA from being attacked by other enzymes. And if you teach about enzymes and temperature changes, kids kind of get that enzymes don't work when it's cold. That's just not how enzymes like to work. Enzymes like warm temperatures. So hoping I get some DNA in mine, but maybe not. I don't know. We'll see. When you add it, your directions say to mix. I've never mixed. I just add it real slow down the side. And when it happens, it's going to happen instantly. Like pretty quick separation. So whatever your container is, add about half alcohol, do a little pour slow. Oh, I'm pouring too fast. And you should see a separation out. Now, one of the things that I can tell that I did was I probably put too much wheat in mine, so mine's still real yellow. But you know, and I'd love to see y'all's results. The other thing is it will hold for a while. You will have DNA floating in there for days. Like the DNA is not going to go away for a few days. DNA is floating in this one still, and I think this one was from Tuesday, or no, I mean Monday. Today's Wednesday. So the DNA is floating, and I don't know. What are y'all getting? Anybody want to hold their results up? Anybody getting any, looking for a white booger? Looking good, Robert. Is that something floating right there in the middle? Or is that your thumb? That's DNA? DNA. The principal got some DNA. Love it. Mandy's got close inspection. Jenna's still wearing her safety glasses. I love it. I love it. Hey, Tammy, nice to see you. Aaron. Do y'all have, y'all can turn off your microphones if anybody wants to say what you got or if you got any results.
I doubt you guys can see it, but I can see it.
Valerie, I see you holding it up, but I can't tell. Do you have, and who was just talking?
Mandy.
Oh, Mandy, hey, can you see it?
I can see it, but I doubt you can see it of mine. It's really.
I think I see. It's a little
down
dark.
here laying on the bottom.
Yep.
Yeah.
All right, well then the other challenges, and kids love this is disgusting, is they go fishing for the booger. You can go fishing with whatever you want to go fishing with. You can use a paper clip, you can use a straw, you can use a pipette, you can use your finger picker, you can use your favorite booger picker. It doesn't matter what you go fishing with. You need to go fishing. And,
should be laying on the interface, should it not?
well, it will, I have noticed that it changes sometimes in that column, just kind of depending on how much you're shaking it. It will settle off in mine, and this one, it goes to the top.
Yeah, if you pour it slowly, it'll sit on the interface.
Yep. And when you mean interface, you mean that top, that layer right there where the wheat germ was, right? Is that what you're talking about, Robert? Maybe. I don't know. All right, well then you're gonna go in and get it out, and your directions say to put it in a little tube, and I think y'all got these tubes. Kristen, did they get these tubes?
Mm-hmm.
And you just stick it in a tube, and you can put more alcohol in there. The alcohol is clear, and again, the alcohol is going to separate from the DNA. So if you wanted to put alcohol in their I don't know where my alcohol went. Whatever. How can I lose something? I'm just sitting right here. So I'll go around sometimes and just give them another squirt of alcohol once they get it in their necklace, and then they can have a DNA necklace. But I would avoid that the wheat germ mix that's kind of yellow. Clearer you get, the better. I don't think I'm holding it in front of the camera. Then you attach a string, close it, and you have a necklace. Now, I will say the kids like the wheat germ, and the wheat germ's COVID safe, but you can also scrape your cheek mouth. You can give them toothpicks and let them scrape, tell them they're not digging for blood and they're just scraping off cheek cells. And you can give them something to salt water to put in their mouth and swish around and spit it back. And you can go through the same process. The meat tenderizer, all of it, salt, the whole thing, and then add the alcohol at the end. And then they can have a personalized DNA necklace. And that's one of the things my students will do. And you can buy these. These are DNA necklace shaped double helix necklace. And then my students, this is gross, but this is true. They leave this thing all over my room. It's hanging off the skeleton over there. They leave the DNA in my room. And I tell them that's dangerous because I don't know whose DNA or who's getting convicted of what, but I have DNA samples all over my room, hanging off different places. I know it's gross, but whatever. It feels like home in here. It feels like home. So you should probably, I have some more separation. I know y'all can't see mine, but I've got a good amount of snot in there. Again, because we started with a lot of chromosomes. So if you wanted to make a necklace, you could. If you wanted to let them do their cheek cells, you could. If I did cheek cells, I do set up a bleach bucket. And when I set up a bleach bucket, I just get a bucket, put water in it, and I splash some bleach in it. And then after they scrape their toothpicks, they stick their toothpicks in the bleach bucket. And we also put our cups in the bleach bucket. And I'm not really super concerned about, their toothpicks or their cups. I'm trying to teach them good practice that all biologicals should go in a bleach bucket. Because let's face it, the cafeteria is into this hole, and their cups are going everywhere in the cafeteria. So, anyway, does anybody have any questions or modifications to this lab or anything?
Yeah, we have one question to talk about what might have gone wrong if you didn't see DNA. And I will say this shouldn't be the case in this scenario, but if your wheat germ is expired, it may not work. This was brand new and wasn't expired, but I know, and it does last a long time, but Trisha ran some earlier today and it wasn't working. She ran 7 of them and then looked at her wheat germ and it was expired.
Yeah. So so that will do it. If it's not working today, I would leave it alone and let it sit. It could be that you didn't shake hard enough, you didn't break open those cell walls. I found a lack of soap was the biggest factor for me. Was if there was not enough soap to break into those lipid bilayers and break down the cell membrane, you were not getting into the DNA. So if it didn't work, I would try some more soap next time and be a little bit heavier on the soap. But let your kids run it without meat tenderizer, or let your kids run it with salt. And it's okay if it doesn't work every time. It could be your water wasn't warm enough or your alcohol wasn't cold enough. So if your alcohol didn't come directly out of the freezer. And I did have some teachers ask about putting alcohol in the freezer. It can be the full container. It's not going to freeze or bust. You can stick the whole container of alcohol in the freezer. So those are the big pitfalls: is the expired wheat germ, the cold alcohol, and I think soap. I really don't think it comes down to salt or meat tenderizer. But again, fun to let kids figure that kind of stuff out and graph it and measure it and try to quantify their boogers. It's tough. That's not an easy job.
Okay, Elizabeth. Actually, what I did, and I'm one of those who always are there. If there's going to be a student that's going to not do it right, it's going to be me. And so I had probably put too much water in mine. And so when you said, we had to add alcohol, I'm like, well, I don't have enough room to add alcohol. So I took and I poured some water out, and then I put my alcohol in, and I'm looking in here and it's so cloudy, so cloudy, so cloudy. but I added a little more alcohol, and just since we've been here, I kind of see some forming kind of in the middle, finally.
Yes,
So-
you do, and I'm glad thank you, Tammy. I'm glad you brought that up. Your alcohol does need to be a 50-50 ratio.
Yeah.
So if you had, whatever your water was, you need to have that much alcohol. So, and this can be limited, like sold out in summer, and this can be a little bit harder to come by now. If you scaled it down, and what you could do is before you add your alcohol, the kids could pour some of this or pipette some of this solution off. And we talked about last week that you don't have to have a $70 pipette. You can have a straw from McDonald's, and you can come in here and pipette this off and stick it in a smaller container and then add a smaller amount of alcohol, because the alcohol does need to be 50% of the solution.
And I also think when I poured it, it kind of mixed in some of the wheat germ. It kind of mixed up a little bit. And maybe it needed to, I don't know, but maybe it needed to settle before I put the alcohol in. And of course, you know, when you said put the alcohol in, of course, I just dumped the alcohol in. I didn't pour it in slowly. You know.
Didn't say slow pour, and I didn't have y'all do a lab write-up, and we didn't really think too much ahead of time, but a slow pour is good. Another thing that I teach my kids is a tilt pour, and let it kind of go down the side, gentle, you know, like sloping it in. This lab is so cheap. I mean, literally so cheap that any mistakes, a kid can do it again. And if you had warm water going in your room, like coffee pots are good for that, microwaves, whatever. You just have a source of warm water, they can start over at any point. And this is easily rinsed out or put it in the trash can and start over.
Yeah.
So, and it's such a short time. It's easy.
Well, I'm always that student. So anyway.
I'm glad you're in my class. I'm having a hard time sometimes with instructions. So as maybe y'all can tell. But does anybody else have a question?
So mine's kind of cloudy. And when I heated it originally, I got it to the right temperature, but I couldn't leave it. So as the previous lady was talking, mine was not on heat the whole time because I didn't have a way to do that. But it is cloudy now. Is that?
Yeah, I do think you need to start with the warm water, and all that is to soften that wheat germ up, because it is a seed. It's inside the seed. It's the germ in the seed, but it's still got a casing around it and a covering. So it's important that warm water is to help break down that tough cell wall that we have in plants. So you probably were temperature dependent. But again, fun for kids to figure that stuff out and do.
Absolutely.
Who else? But thank you, Erin, for sharing. And sorry you couldn't keep your water warm. That's tough. You fail for warm water. Fail.
I have one.
Oh, Maddie.
Okay, when you're doing the cheek, do you just put it in a small amount of warm water and then do the same thing?
Yeah, well, what I do is have the kids go to the water fountain with a bathroom cup, and then they swish it back into the cup. And the warm water is not as important because we don't have cell walls. So the cold water from the water fountain works just fine. So they'll scrape their cheek and then take the cup of water and swish it around real good and return it back. And now you've got your DNA sample in its raw form. And now we just need to extract it with meat tenderizer. I would recommend a little meat tenderizer there, but I've never tried it without the meat tenderizer. If you want to get real fancy, you can order from chemical companies something called protease. And protease breaks down proteins. You can teach kids that, you know, it has the ACE on the end, breaks down proteins. But you can also buy meat tenderizer, and they get that. They get this because they're meat. You know, they understand their body's protein. And as a biology teacher forever, I had a hard time getting them to understand what proteins were. So, yep. So you don't need the cold water. You can just, you don't need the warm water because our cells are so soft. Is that anybody else got a question? I'm looking at the chat too. Chat looks good. Anybody else got a question? Anybody got any thoughts about had anybody seen the movie After Innocence or is that a new resource? Were y'all familiar with After Innocence? It's interesting because I graduated from high school in '92, so there's a whole generation, you know, where that we didn't think about DNA exonerating people. We were using eyewitness accounts and blood typing, and you know, went to jail on pretty shaky evidence sometimes.
Mm-hmm.
So it's it is a real thing. It's not something our kids really think about, because in all the criminal shows they see, it's DNA evidence in the court. So they don't think about the people that are still sitting there that did not have that. But
Did you see the question about, is it possible for the water to be too hot?
yeah, I have never tried the water boiling. That's what I was going to do that this week. I would think that you would denature, or you would destroy your DNA sample.
Mm-hmm.
You can, I think you could overheat your DNA sample, but I would try it. I'd get the kids to boil the water. I'd put the kids on ice, put the kids in warm water, get them to write a hypothesis ahead of time and a prediction what they think about cell walls and the structure of DNA. It can go so many ways.
Another kind of cool connection to that too, with peanut allergies, for example, that peanut oil is really highly allergenic to those who are sensitive to peanuts, and Chick-fil-A fries in peanut oil. But because it is heated to such a high level with the frying, it does denature the DNA. So like my son, who's super allergic, he can still eat there, thankfully. So my guess would be that, I know it's a lifesaver. My guess would be that the boiling water probably will change it, especially for something more like the strawberries, being that those cell walls might be a little bit thinner as opposed to wheat germ.
I love it. I love that. I'm using that example. I'm stealing that. I'm
Yes.
totally stealing that. That would make sense to kids.
Yeah, yeah.
That's good.
Just make sure you're telling them not to have permission, just in case. But our allergist said that as well.
Yeah, well, it makes sense. It makes sense to go with the structure and what's happening. Who else has a question or anything? And is it okay, Kristen, if we finish early?
That's totally fine. Oh my gosh. Yeah, those are
Last
really the
week we
best.
went over, the pipetting was crazy, but this one was a quicker. One thing I do want to say for next week is I think you're really going to want a microwave. I think a microwave is going to be something that you're going to want near you, and that may mean you set up in a separate place or you move a microwave. But I think a microwave is going to be really important, because you're going to have to melt your agarose. I've never melted agarose on a hot plate, and the quantity of agarose that y'all are using is so minuscule. I think you could burn it really quick, but you could try on a hot plate. But you're going to need a heat source next week to melt your agarose. You're also going to need a graduated cylinder. You're going to need your jug of water, because we're going to dilute the Tay buffer out, and we're going to do a little math next week. It's going to be fun. So
one of the things too that's really important about this is, again, career-wise, these are all some of the entry-level positions, requirements for entry-level positions. So whether it's a lab technician, or we were talking about with Stephanie Torres, quality assurance and so on. Same with anyone who was on the water tower presentation last week. All of those things, making and diluting solutions, and the math piece of it are just really basic requirements for careers. So when your kids want to know what the point is, it's money. It's a way to make a living.
Libby put in there that 1988 was the first time DNA evidence was admissible. And I didn't know that, so that's a good fact. The Phil Donahue show in 1993 is kind of who brought it to the public's attention and started the Innocence Project. So it was, and then they start writing him letters, and then he hires a lawyer team, and it explodes from there. And the next thing in there, Pam's asking, it needs to be distilled water next week. So you need your jug of distilled water next week. And next week, I don't think we have any industry speakers. Like, I think it's just us doing two labs, and they require prep, and you can of course buy things that are pre-poured and pre-diluted and at the right concentration factors. But if you want to teach kids how to do this, and if you want to save a lot of money, it's super easy to make your own. So it's a budget decision, and the kids enjoy making it. They enjoy making their own gels and their own Tay buffer. So, and it really was adding a lot of water. We're going to dilute it. I think you started. She sent y'all 50x. I can't remember. I think she sent you 50x. We're going to go down to 1x. So we're going to use a lot of water next week, and so. But you'll want a microwave if you want to participate in the activity for one of them. The other one, you'll need your Kool-Aid for next week too. So if you want to just add water to your Kool-Aid, you can, and it makes a lot of Kool-Aid. So but we can do all of those things. You don't have to really do anything ahead of time. All you need is a microwave and some stuff in your water, microwave and a water. And I think we could get through the rest. But next week are some of my favorite labs. Is anybody
So
else?
does it matter next week if we're running back and forth, if we don't have like a microwave like immediately in our area, but maybe it's like 30 seconds away, we can run back and forth? Is that okay?
Well, what I think we'll do, I'm glad you asked that, is might take like a 2-minute or a 5-minute break, and I tell you what to do, because you need to be at the microwave because it has a flash point. And every 30 seconds, I like students to take it out and give it a little tap for safety. So I wouldn't want you running back and forth, and it only takes about 2 minutes to melt it. So if we all, I'm really glad you brought that up, Tammy. So maybe you don't have to move the microwave next to you. Maybe what I could plan to do is show you using my microwave, and then you replicate, and then we just meet back in a few minutes, and we meet back with I'm glad you thought of that, because that's good. That's good. So if you have a microwave somewhere around you, I think that's what we'll plan to do. Would that work for y'all? If I showed you what to do and you disappeared? I will
Do you
say,
know the melting point?
I don't know the flash point of it, but it does start to get pretty clear. And I have found, and I've never had a problem with every 30 seconds increments, and it rests and then do a swirl and start again. So but I'll look that up for you.
A boiling bath wouldn't work?
It would work, but it's going to take a lot longer to work if because it needs to get you can boil it. I have never boiled it, but it can reach a flash point. And what I never even let it boil in the microwave. No boiling in the microwave. Just get hot, tap, swirl, put it back.
I meant the water bath boiling to give you the heat.
Yeah. Oh yeah. So I've never done it that way, but you can try it. You can try it, and maybe I'll do it that week before. Maybe I'm going to try it before next week and see if I get it done. But yeah,
Just a thought.
yeah, because your specific heat. So yeah, that could work. But I was going to say Jenna wins. She always wins for safety glasses. But next week, please do not stand in front of the microwave with something that has a flash point without safety glasses. Next week that will be, you will need your safety glasses on at the microwave, even if you're at your house. So I would not want anything splashed in your face. And maybe
flashpoint sounds pretty exciting.
I know. And maybe a hot mitt, an oven mitt. I make my kids reach in the microwave with an oven mitt and tap it. So that if that last bit of energy is going to cause it to pop, it pops in the microwave, and they have a mitt, like an arm mitt. So that's, and if it doesn't do anything on that last little jolt, then I let them swirl in the microwave. But we'll do that next week. So yeah, and that's to get the gel, and then we'll do some dilutions. We'll do some chromatography next week, and I think you're all going to like the chromatography because it's cheap. And once you got a little class set of those things, everybody can do it, and they're reusable. So
You learn all about the flash point at Berry College?
Oh, I didn't go to Berry. I went to West Georgia. So yeah, that was the other speaker. No, I did pour a lot of gels in college though. That was one of my one of my jobs was pouring gels. So, and I also sprayed ethidium bromide on the gels, which was dumb. It was in a spray bottle. They were pretty though.
One of the things that Megan works pretty hard to get in the depot are class sets of safety goggles. So if that's something you don't have, just let her know and we can try to find what we can for there or order when we get some funds in for that. We don't have class sets at this point because we've given away all of our inventory, but that's on our search for now. So just shoot her an email if that's something you need. And Elizabeth, I did volunteer your PowerPoint since you gave it last week.
Yeah, did it get loaded last week?
I think
Or
so.
no? Okay.
I think it's up there, yeah.
Okay. Yeah, I will put my PowerPoint in again. That is, yep, for sure. And I haven't had a PowerPoint in my classroom all year. I don't do PowerPoint. So this is different for me, but I can't think of any other way to reach y'all. So I'm not a PowerPoint teacher. I'm not a standstill, and I don't stay on track at all. All right, well, does anybody else, y'all? Microwave and water, but we'll take a timeout for the microwave. And we're excited because it sounds like it's going to explode. So it's going to be good. It's not, though. You could make it explode. It'll pop your glassware, but I don't think y'all are going to do that. No.
Do they need an oven mitt around too?
Yeah, I like them to reach in an oven with an oven mitt. And I don't think they could ship y'all a beaker. And when you next week, let me go get one.
Funding for new microwaves.
This is the best thing to do it in next week is an Ellemeyer flask, and the net is going to keep you from losing too much in evaporation. An open beaker, you might evaporate too much out very quickly. So if you have an Ellemeyer flask, and I try to get the biggest one that will fit in the microwave, but we're making a smaller batch. Y'all are just making one gel. So probably a 200 or 250 mil would be fine. You're supposed to do double your volume. And I think you're doing 100 mils a tay. I haven't looked yet, but.
If you don't have an Erlenmeyer flask or a beaker that's made out of Pyrex and you're using a glass, be real careful because the glass will not explode, but it will come apart if you put it on a tabletop that's cold. Glass doesn't like to change temperature very fast. That's why Pyrex is used the way it is. So just a little reminder there.
And I have never melted, no, I take that back. I melted a large batch of agar in an iced tea plastic jug over COVID. So, and I was worried because I didn't have any Pyrex like Robert's talking about. I went and got a big plastic jug, but I didn't do agarose, I did agar. If, you know, and nothing in it's going to hurt you. Agarose has got algae and carbohydrates in it. There's nothing in it that's going to be residual in a food product that would be harmful.
Elizabeth, do you have a technique like similar to melting chocolate in the microwave where you'll do 30 seconds at a time?
Yep.
Stir it, test it, another 30 seconds. What's kind of the cadence that you might recommend for anyone that might be apprehensive about explosions?
Yeah, I use extreme language just to entertain people, and I'm sorry, I should be more professional. You're not going to explode, and you're going to be stopping it every 30 seconds. So what I do is I tell you to leave it in the microwave, and you put a big oven mitt on, like an oven mitt, and you tap it. And that lastly, when I say tap it, you give the little bottle a nudge. And if it's going to get to that flash point, it's that little tiny incremental change that's going to do it. So if you nudged it wearing a mitt, nothing's going to happen. You're going to have a mess in your microwave. It's not coming for you. And then if you nudge it and it doesn't do anything, I tell you to pick it up in the microwave and swirl it in the microwave, set it back down, hit the 30-second button, but you keep watching. And if you see a single bubble, you stop and do it again. We don't want it to boil. We just want it to dissolve and very close to boiling. And 2 minutes is the max in a microwave. And then it turns clear, and then we'll just let it sit on the counter, or with like, and what Robert was saying, if it's a cold counter, no, but unless it's Pyrex. But I just put them on the lab table and let them sit. You're supposed to use a thermometer, and you're supposed to measure it at 55 degrees Celsius. But if it's cool to touch, it's ready to pour. So, and as a teacher, you can make a larger batch. And I think a larger batch would be safer on a hot plate because it's not gonna start melting and sticking to the glass. It's gonna evenly melt in a larger batch. So, and you might not want students pouring agarose gels. My students pour, and our limiting factor is the microwave. But once you pour gel, you can put it in a Ziploc bag and it's good for a week or two. So I'll tell them ahead of time, have a gel poured by X day, and they'll do that. Oh, and in your folders next week, y'all have a little tiny piece of plastic. This was 3D printed for you. It's a comb, and you'll put this in. This is going to make our holes. So I'm sure y'all have your binders right next to your computer and you're studying them diligently. What else? Are y'all good? Is anybody else's DNA? Did anybody not get DNA? I know Tammy messed hers up because she didn't do enough alcohol. Tammy, more alcohol is always the answer. But where?
I've got DNA.
Oh, she's got DNA.
I've got like a big, huge glob. I didn't have anything to put it in, so you can't see. But there's a big, huge glob. I mean, it's like a booger about that big.
Good for you. And I saw Christina. You didn't get any, Christina?
No, I use the water that I use to make my tea as well. And so it's really hot.
Okay.
Hot.
I'll try again.
And I know Aaron got some, or no, Aaron didn't get some because the water wasn't warm. Jenna got some. Pam, you got some? Did you get some? Pam's ready. Valerie, did you get any DNA? Why not? What do you think is wrong? She don't know? Your mic's off.
Jenna, I have no idea. It looks like this.
Yours, you had yours cloudy too, and now yours doesn't look cloudy anymore.
I don't see any bubbles at the top, Valerie, and mine still have soap bubbles at the top. So I think maybe you didn't have enough. Oh, I'm so glad you showed that, Jenna. That if you had more, that's a Pyrex. But your agarose sample is so small. But you could do a larger container in that. But
well, after you said it needed to be 50-50, this doesn't go up to 300, and we had to put 150 mils of water in here. So I'm like, I need a bigger container.
Yeah, I just would have put. I always do just half my container with the water and half with the alcohol.
That may be what was wrong with mine then too. I was looking because mine and Jenna's looked a lot alike. They were both cloudy. So maybe if I add more alcohol too.
Mine was too, because I went ahead and did what they told us to do in the beginning.
That's what I did.
Yep.
Oh, you
had those measurements, yeah.
Oh, y'all did. Okay. Y'all are advanced students. Well, that's what you get.
Actually, I think the alcohol is where it causes it to precipitate at the interface. The amount of alcohol, as long as it's on top, it is between the alcohol and the precipitate and the slurry that your precipitation is going to take place. You can add all the alcohol you want, but I don't think it's going to help any. It's what you have underneath. It's kind of like when they make nylon. You get nylon is at the interface, you pull out a little bit, and you get this long string. And it all comes from the bilayer right at the interface between the two liquids.
It's a great explanation. Thank you, Robert. I think a pantyhose, that was good.
So Elizabeth, is that white layer the DNA then?
No, it should be up at the top.
Yeah, I don't have anything floating up top.
That'll be coming up to the top.
I put mine up. Mine's settled out. Yeah. If you look at my camera, mine is settling out. Oh, I'm sorry, Libby. Y'all's is pretty cloudy too. Y'all, yeah.
Cloudy's good, right? It means it's coming.
Cloudy means you mixed it really good, but I didn't see, Libby, I didn't see a lot of soap in yours either.
I did like almost 2 squirts.
Oh, okay.
I did help.
Hold it back up.
I was doing it when you were talking and you said a good healthy amount. So I did a little bit more.
Let's see yours again.
I had to switch containers too.
Oh, so you transferred containers so it didn't settle out?
Yeah.
You might want to leave it overnight and see what it does.
Yeah, I'm gonna leave it and let it sit. I'll tell my husband.
If it's like DNA extraction from strawberries, you can put them in a gallon baggie, crush up the strawberries, then you take out, you decant through a cheesecloth or something into another baggie, and you put the alcohol in there, and it causes it to precipitate out. It's very easy to do. You can do the same thing with bananas. Anything with a lot of DNA. This is great. This is enjoyable.
Thank you, Robert. That looks good, Patty. That looks really good. I'm with Robert. I prefer the strawberries, and then we put the strawberry shampoo with it. It smells good. It's fun. The bags, they'll smash those bags pretty good. And you can filter through a coffee filter too. You don't have to have the cheesecloth, but yeah, anything that has a good amount of DNA is good. But the wheat germ is always available in the freezer. And so you can do the strawberry lab when you're prepared, and the makeup lab can be the wheat germ, if that's what you want to do. Then they think they're doing something different, and then they can't cheat. Shut them down. Y'all had lots of questions, tons of questions. Okay. I think we're mixed, half and half on DNA. I don't know what Kyle got, but I don't know what Christina got, but I think we're mixed. Well, I enjoyed my evening with y'all again today. Y'all are entertaining, smart group, entertaining, and ready to go on science. Y'all are all doing your stuff. You're good students. You put cameras on and you try, and you share your results, and I appreciate it. So microwave and water next week, jug of water, distilled water. Anybody else?
Kyle wants you to make sure you know he got good results.